Oh, sorry, I'm just pushing it. Okay, so you can see, so I'm able to retrieve something like, so I'll just come back to this now. So I just wanted to show you the difference between nested and object here. So I'm able to, here I'm just executing something like an end clause. So I'm just trying to fetch records with first name as John and last name as Smith. So let me try to change this a bit. So I'm just using first name as John and last name as White. Okay, but still I'm getting. So if you see, my actual intention is to get data in such a way that, so I have first name, I want to query something like, so Pavan Arya, so maybe like Pavan and then Arya, the document as. Okay, but somehow Pavan Arya, so okay, but still like I'm getting this particular document. So I don't want to get this particular document. That is because like I'm actually looking for Pavan Aryasomyajulu, but here like I'm getting Pavan from this particular user and then Aryasomyajulu from this particular user. So this way like I'm not able to get intended results, right? So this is where like nested data type it comes into VizQ. Okay, so let's try to index. So if you see like the index for mapping for this particular document, so this is just indexed as an internal nested object, but that is nothing but like an array of objects. So let's see like if we can index this using nested. So I'll just update this particular same index. Okay, so I'll have like mapping. So you got a sense, right? So why this is not actually working out? Or any questions here? Hello? Hello?
No questions from my side.
Yeah, so you're actually clear about the problem with what's the problem with this type of mapping, right? So I'm getting like wrong results. So unintentional records like I'm getting. So now I'll just try to make use of this particular nested mapping here. Okay. So properties. Okay. So I'll just have some other, so user is my nested object, right? So I'll just have like stack over underscore user. Okay, so this is my base property, and I wanted to create this particular field as nested object. Previously, like it is not being considered as a nested, so I'll just copy. Yeah, so stack user, and this is first name. So inside this, like again, I wanted to go with like nested properties. So properties, and my first field is like first name. So I just want to have this field as like text. I also want to have another column. Last name also as text. Okay. Just give me a second. This is okay, so this is my parent property name, like stack overflow underscore user, and inside that, like I wanted to have the same configuration, like first name and then the last name. But this time the only difference is like, so I'm just trying to have this type as nested. So that is the only difference. So so then mapping got created. You can also see mapping. Okay. So this is good. We can ignore that. So this is Stack Overflow user and this is user. So in user, if you see, so after user, like we have properties and inside properties, first name and last name. But with Stack Overflow user, I'm just having the type as nested. Okay. So now I'll just try to index the same document. So let me try to use this document. So this is the first document ID is 1. And then the second document ID is 2, right? So I'll just use update. Okay. So I'm just trying to show you what is my, this is my full stack overflow user. Inside this, like I'm just using first name, last name. So it got updated, right? So let's see the search. Okay, so we have match all query, right? So let me execute the match all query. So this is my second document and this is my first document. If you see the first document, so almost it looks same. So I have like group fans and user, first name, John, last name. This is a previously inserted document, right? And this is the newly updated field. Like I'm adding like stack overflow user, but even here like it looks the same. First name, last name, first name, last name. Right? So also let me try to do that with the second document. Okay. This is a query to update an index, existing index. So I'm just specifying like the index name and then update. I'm trying to update and then document ID. And inside this document, like I need to specify this type like doc, and I'm just trying to add new fields, right? Here, same like I can also update existing fields, but here I'm just trying to add new fields. This is for second document. The second document got updated. So let's see what the results are. Okay, so ID index 1, so user and stack overflow user. And here also like we have for second document we have like user and then stack overflow user. Right? So let me flush this data and see how it actually looks in loop. Okay, so I just flush this data. So let me re-index this data. So now you can see. So we have like user dot first. So what's it with the stack overflow? It is something like user dot last name, right? So let's compare these items. So stack overflow dot last name, and then the user dot last. So let's see what are all the documents. Whites with Arisomia Zulu IE. This is the data, and also the last user. So even it has like same data, right? So it's with RSOM user only. But let me try to re-execute the old query, so which we saw. So there is one search query which I executed, right, previously. Yeah, so this is a bool query. So what we saw is like, so when I'm actually trying to query with cross documentation, so this is it is actually taking Pavan from here and then the RS only using from this particular use. So I just don't want to have that particular behavior. So I'm trying to I added this nested object. So let's see how this actually behaves. And now this is first one. And then last one. Okay. So now I'm trying to execute the same query. So this time, like you can see, so it didn't return any documents. So let me try to change this.
So Pavan, we need to specify path in order to query nested objects. So path sans is to wanted to in order to query nested objects, you need to specify path like in the query.
Yeah, so this is my query. Yeah, so I'll just get back to this later point of time. Okay, so let's continue with other things. But my intention with nested objects is like, so what it needs to do is, so it is actually supposed to consider these documents. So instead of getting cross documents, so this is actually should get actual data. Okay, so I'll just get back to this debug that. So we saw like how to update the mappings and add like new mappings, and also we saw like some differences between like nested objects and then array objects. Okay. Yeah, so there is something called as like, now let me get back to this property like mappings. Okay. So previously, like what we are seeing, so every time like we are seeing like this text and then this keyword, right? So what is actually happening with this? Why do we need to specify this text and why do we need to specify this keyword? So this is actually giving an extra feasibility to index the same field with multiple types. So let's say like in this example, like I have like group, right? So this group, so I'm just indexing this as text and also I'm just indexing this as a keyword. Okay, so the difference between text and keyword is like text is analyzed, whereas keyword it is not analyzed. Okay, so I'll just show you this in this demo. Okay. So when we actually indexing with the text and then keyword, so in the background like you can see, right? So you have like text one with the text. So this is the default one, which is text, and here like you can see keyword. Right? So now let me try to create a small index. I'll just delete this existing index. Okay, I deleted this index one. So let me try to create a mapping with small. Something like this is my favorite. So I deleted my Stack Overflow top image. So I'm just again trying to insert a new document here with one field, and this is the text. Okay, so it got created. So if we want to see how this is actually indexed, okay, so if we see the mapping for this particular thing, this is the only field, like field 1, so and it is indexed as text and then keyword. So let's see the difference between like text and then keyword here. So I need to flush this particular object to see it in view. Flushing so that like I can see it in view. So I deleted that document, right? So it will again ask me to pause. Let me see what's in index ID. So start with P1Q. So this is my index. So if you see like this particular field, so when I'm trying to index this particular document with one field, field 1, and we saw the mapping. Right. So this particular field 1 is mapped as text and also as keyword. So how is this actually impacting? So with text, so it is actually analyzed, whereas with keyword it actually stores the raw record. So let's see how it looks like. So if we see the field 1, so it is actually analyzed. What is analyzation? Analyzing. So I will get back to that. So you can see. So this is actually like field 1. The document is stored as like Pavan is good Arya, right? So it is broken down into terms and then it is actually stored. So whereas with keyword you can see, so it is stored as like one particular like sentence, right? So this is a keyword thing and this is the text thing. So we'll see advantages and why we actually need to have this particular keyword and also why we need to have text. So one advantage with the text, so I want to query this particular document. Okay. Search. And I want to have like match query. So I want to query this particular field. So I can simply, I want to, so let's say like we have a huge document like Stack Overflow document. And I wanted to query with one particular word. So word, okay. So here like I want to query on Arya. So I'm able to get this record. So let's say I want to say Arya. But still I'm getting this particular record Arya Arya. So even though this doesn't match, so this is actually, I'm still able to get this record because I have this field. So I will get back to that on few slides. Okay. So that is with like match query. So match query, what it does is like, so it will actually make use of this particular text field, okay, the field that got indexed as text. So actually it is executing the query on these terms that were internally created by ELC. Okay. So if I want to make use of this particular, so if I want to make an exact query, so I don't want to make so these terms, I don't want to search on these terms. So in this case, like I can do something like field.keyword. And I need to specify. So here, like I cannot give something like Arya. So because field1.keyword is indexed as this entire text, Pavan Arya is good. Okay. So let me try to query with that particular text. Okay, Pavan Arya is good. So you can see, so I'm able to retrieve this particular document with exact sentence. So let me try to change the case. So let me try to make these items case instead lower letters. Okay, and try to search. So now I'm not getting data. So if you want to make like exact searches, like so then it is better to have like text as well as like a keyword search. keyword search, what it does is, so as we saw, like keyword, it is actually storing the exact document, whereas like field, so it is internally transforming the data, so it is trying to analyze the data which we inputted, so it is actually trying to break the sentence into these things like individual terms and finally storing it in the loop. So it, so we saw like keyword is case sensitive, right? So let's see like if text is case sensitive or not. So Pavan, so I'm able to still get. So text is case insensitive. So let's say like I search for Pavan. Because like let's see. So because like we saw right here like the value is stored as small letter. So let's try to query with the capital P. Yeah, still I'm able to get the result. That is because, so whenever we are executing any query on top of like this text fields, what happens is like, so the analyzer that is used for indexing this particular document, so the same analyzer is used at the time of querying also. So internally what happens is like, so this is actually even for this query part, so it is actually converted into lowercase and then the query is sent to Lucy. So that's the reason why like we were able to get this data. So that is how like we can specify like multiple, we can index the same field in multiple ways. So we can see this. So we are able to index this field one as text and also keyword. Okay. So let's say like I want to have like some analyzer defined. Okay. So analyzer in this sense. So let me try to have change the mapping here. Okay. So it should be, I wanted to have like new field created, and I'll just have so field 2. So I want to map this particular field as keyword. Okay. So I just map this particular keyword field to as keyword only. So let's see like how the mapping actually looks like. Okay, so you can see. So field 1 it is of type text as well as like keyword, whereas like field 2 it is only mapped as keyword. Let's try to index a document and see how the results actually looks like. Okay, I just so got indexed in the document, so we can see like what are all match queries. So I'll just show you. So there are two documents, one with field 1 and the other one with the field 1 and field 2. I have like Karthik is good. So and also my mapping, it looks so mapping. So the first field is mapped as text as well as like keyword, whereas like the second field is actually mapped as just keyword, right? So let's try to write small query on top of this. So this is the search query, right? So I'm just trying to match on field 1. Pavan. And I got this document. Two documents because. So let me try to execute this particular same query on field 2, and I'll just do like I'm not getting any results. That is because so that particular field is actually indexed as, because that particular field is indexed as keyword. So we are not performing any analyzing. We are not analyzing that particular field, or so we'll see how it actually looks like, how the data is actually stored. Let me flush this data. So you can see like, so we have field 2. So you can see like field 1. So there are two items like field 1, regular one, and then field 1 dot keyword. Whereas with field 2 we have only one item, field 2. Okay, so if you see field one, so it is actually analyzed. Whereas if you see the field one dot keyword, so it has like actual string stored. So if you see field two, so it is actually storing only this entire string as it is. So if I want to execute any query on top of this, so I need to give the exact sentence. So why did this query match actually? So this query is actually matching because it is actually trying to split this particular word on field one. So this is trying to split into Karthik, is and good. So and then it is also trying to apply some analyzers. So it is actually trying to make everything as lower cases and searching, right? So here like good is matching with this Pavan Arya is good. So that is the reason why like we got this first document also. So, but that is not case with the second field. So, in order to query the second field, I need to provide exact the same sentence. So, even if I change the case, so this will not work. That is because like fields that were indexed as keyword, they are not actually analyzed. Any questions till now with text and keyword?
No, I think good, Pavan. In the interest of time, Pavan, just checking how much we have more.
So I have lots more. So maybe like if it is okay, I see like how many participants. So I see only 9 participants, right? So if it is okay for everyone, so we can continue for another half an hour or something like that. Or else like we can stop it here.
Yeah, if others in the call can have their thoughts. I'm okay, but just
Yeah.
check that others in the call.
Yeah. So just let me know your thoughts.
Yeah. Or Pavan, if you are fine, say you have covered the indexes and mapping, and also the fields and the names. Are there any specific sections that you think everybody in the call should be aware of in terms of Elasticsearch? Then maybe you can cover them, and then you can share the slides.
Yeah, so one more thing is like analysis. So it is altogether a separate concept. It can be treated as a separate concept. So maybe like we can go with analysis in the next session. So I have like almost 30 more slides, which is obviously not possible now. Okay. So this is, I think like it is good up to now. So we got to know about like mapping. So what's the advantage of mapping, and then what happens if we don't specify mapping. So I'll just cover like one small item with this mappings. Okay. So till now, like what we saw is like, so anybody like if we are trying to add a new field, if we are trying to put a new field or new into the document, like when we are trying to index a new field, so it is actually automatically updating this particular indexes mapping, right? So we saw that behavior. So how do we actually stop that? So how do I have like only strict mapping? So I'll just show you that example. So let's take this scenario. Okay, so here we saw this mapping, right? So stack overflow top. It will not take more than 5-10 minutes. Okay. So here we have like field 1 and field 2. So now I'm just trying to add another field. So I'm not changing the mapping, but I'm trying to add a document with another field. Field 3. This is so this particular document it got indexed, so I can issue search on command. So we have like 3 documents: first document, second document, and third document. This is added later. So what is happening here? So if you see the mapping after updating the document, inserting a new document, so field 3 it got added automatically, right? So this way, like I showed you like the one disadvantage. Even if we have like if we have like field name with a different case or a different intention, so it is actually creating all the junk, right? So how do we actually stop that? So that is actually possible with the mapping. So what we can do is like we can simply specify something like this. So at the time of creation, or we can also update this mapping to strict at a later point of time, even after creating the mapping. So I made this mapping as strict. So now let's see what the mapping looks like. So initially, like I made this mapping strict, and after that, like I have field 1, field 2, field 3. So now let me try to add one more field. So because I have already field 1, field 2, field 3, so I'll try to add field 4. So which is not present in the mapping. So you just execute that. So you can see, so mapping set to strict. So dynamic introduction of field 4 with the document is not allowed. So what it is saying is like, so once the mapping is made strict, so it is not possible for you to add like new fields just like this. So with the time of indexing, okay. So that's the main advantage of like strict. So you can specify the strict at any point of time, or at the time of index creation also, like when specifying the mapping, you can just specify this, like it goes something like this. So at the time of index creation, so these are all. So next one, I need to specify dynamic strict. Then I need to specify
So, Pavan, declare on top mappings columns.
okay, I forgot. Coming from SQL background, it's somewhat difficult to remember some of these JSON syntaxes. Yeah, so like I'm just creating these mappings and then specifying this dynamic strict and adding a new field type text. Okay, so this got indexed, right? So now if I try to index this post, so if I want to add a new field, so I can add this field. So that is fine. If I'm trying to add the new field, so it is complaining like the mapping is set to strict and you're trying to insert this field 2. So this is how like we can control the strict behavior of mapping. So there is another property, like, so there are like 3 values for dynamic. So one we saw like strict, the other one is like true. So by default it is true. So we have like stack overflow top, right? So previously it is set to strict. So you can see stack overflow top. So I just had it as strict, dynamic strict. So let me update it back to dynamic behavior. So it got updated. So now let me try to index this field. So add an extra field. So we have like so we have like 1, 2, 3 fields. So previously when it is strict, so I'm not able to add this field 4. So now let me try to add it. Like, okay, so now I'm able to add this field 4. So that is one option. So we have like 3 options. One is true, which is nothing but like it allows dynamic field creation, and then the other one is strict, which will actually restrict us to add like new fields without specifying in the mapping. And the third one is like false. So what happens with false is, so I had this value, dynamic value as false, right? So let's see how the mapping looks like again. So here like the mapping is set to false. I have 4 fields, field 1, field 2, field 3, and then field 4. Okay. So now let me try to add this some other field, like field 5. So in case of strict, so this will not allow. It is not allowed to add new field. With true, so it is possible to add field 5. So let's see what happens with the false. Okay. So even now the document is indexed. Right? So let me show you what in look. Need to flush this. Let us see it in look. Okay, so this is flushed. So let me refresh this. See, you can see. So we have like only these fields: field 1, field 2, field 3, field 4. So even though like I added like field 5 column, like I'm not able to see this here. That is because like when you set like dynamic equal to false, so it will allow us to add this particular field to the document, but it will not allow us to index this. It is not actually indexed, so I cannot search on this particular field 5. Okay. Hope you got it. So, but still like we'll get that particular document in search. So how do we get the search? Is it? So match all will get all the document. So yeah, you can see. So this field is added. So this is added later as a false by making dynamic equal to false. But you can see in loop. So I mean internally, losing is not actually indexing that particular field. So you cannot see field 5 here. The dynamically added fields after setting dynamic equal to false, they will not be indexed. So when it is not indexed, so we will not be able to query that particular field on that field. So it is not possible to query on this field. Okay, so I think like I covered a good part of Elasticsearch indexing and then mappings. So we covered like most of the things in mapping. Update mappings and then dynamic mapping and also some of these things. So the next thing is like analyzers. So analyzers is altogether a different concept. So how we actually analyze. So if you see, so this field like Pavan is good. So that is actually, so this is the actual data which we index, but it is somehow translated into internal terms, right? So we'll see like how they are actually translated into these terms using analyzers. Okay. So there are like some standard analyzers. So in the next session we'll see like how we can analyze the data and we can have like custom analyzers, and also we'll see if something like how we can query these documents. There are like multiple items, like multiple ways to query these documents. Okay. So any questions till now?
Yeah, I want to take one problem. So,
Yes, sir.
yeah. So, doing the indexing in the way that you have explained, can you put some light on at what stage in a project that we need to get into this? In the very beginning, or as the project grows, your data grows, and then you realize that, hey, I need to put in more indexing for faster retrieval, etc. Right? If you can, from your experience, real-time experience, talk a bit about that.
Yeah, so usually like we saw like why we need Elasticsearch, right? So it is actually used for faster retrieval for data, especially like text text data. Okay, so that is one advantage. So if we are actually going with projects like Stack Overflow or even the HR applications we saw, right? So we store resumes. Let's say like there is a resume, so I have my resume and I want to, so there are like thousands of resumes. So usually these recruiters, what they do, so they wanted to search based on some skills, so either with .NET, Java or something like that. So they are using like very small skill set. Like so let's say the resume has like 1500 words. So out of these 1500 words, like Java might be like one small word. There might be like only one occurrence of Java, right? So in that case, like going with SQL Server, obviously that will not work out. So you need to index, first of all, indexing large data is not possible in SQL Server. So executing, we need to have this like operators. So like operators is obviously costly. We need to traverse the entire data. So in those scenarios, like SQL Server or Elasticsearch, it comes into rescue. So that is when we can use Elasticsearch. So coming to this indexing part, like, so when should we actually go for like automatic dynamic indexing, or when are we supposed to go with like mapping? So if you ask me, so for testing purpose, it is okay. So to go with dynamic mapping, you can simply start inserting data with post, just how I did. But in production environment, like it is always better to have like mapping defined, predefined, because we saw a few things, right? How the mapping is actually impacted. So let's say like I have 50 columns I wanted to store. So out of these 50 columns, I might not have data for the first document which I'm inserting. So let's say like I'm trying to insert one document, first document, and out of these 50 columns, let's say like I have data for only 20 columns. For the other 20 columns, I don't have data. So obviously there will be null values, right? So if I don't specify mapping, so what happens? So it will actually try to assume some data type for that particular, for those 25 missing values, and it will have its own mapping created, right? So maybe that might work out for us, or maybe that might not work out for us. So in those scenarios, like it will actually create some huge mess. So obviously, like in those scenarios, it is always better to have this mapping created on hand. So what usually I do is I have those. What I actually do is like, so I create this first sample document, and then I'll insert that particular document. So because obviously like it is difficult to have this properties fields nested, and then inside that having this JSON structure is somewhat I don't usually get to this, because like, so I might miss one braces, and it might create an error, right? So even if you see, so if I just remove this brace and I try to execute this query, so I will not be able to find out so what is wrong with this query or something like that. So even if it shows error, so it will say 1 2 3 4 5 6 7 8 in the ninth line. So but here like I'm seeing 54, so I need to go line by line and then count. So okay, this particular line has error. So what usually I do is like, so I just insert document as it is, like how we did with BC. So in general, what I do is like, so I just delete this document. Okay. So then I'll go with this document insertion, so sample document insertion for the first time. Okay. So after that, like I will just get this mapping, the mapping from this particular document which is inserted. So I'll just have a copy of this mapping. So I'll copy this mapping somewhere, and then I'll see, okay, so field 1, so this is actually mapped to text and then a keyword. So usually, so let's say like I have my field 1 is nothing but like it is tags. Okay, so tags or some enum values in C# or other languages. So you always know that, so it will not be indexed. So you'll have like Elasticsearch every time you query. So it is a constant value in your database, in your code. So you'll always query with the same data. So you will not query with Elastic or search, right? So in that case, so I can simply ignore this text mapping, and I can simply have like keyword. I'll change this to keyword. Okay. So okay, this is field 2. Okay, some kind of body. Okay, so I need to have both text mapping as well as a keyword mapping. So in this case, like some other field like title. So I don't want to. So let's take this as title. This as body. So a body might have like, if you see stack of body, so it might have like more than 1500 characters or something like that. So in that case, so we'll not give exact string, right? Keyword string. So in that case, like I feel it is the waste of having like keyword field. So I'll simply have this text field. So this way, like I'll change my mappings, which is already copied, and then I'll try to create a new document, new mapping. So I'll delete existing mapping, and then I'll just use this modified mapping, so that like I'll have good control on the mapping, overall mapping. So you got an idea, right? Just of it.
Yeah. Now the reason to ask the question is I mean, we use, as I think I mentioned last time, we use ELK, and somewhere in the node code we have a configuration that says what are the indexes that you want. So we just put like 3 or 4.
Okay.
Typically for tracking the request response, APIs, and some essential business functions. But we haven't done this exercise, like the detailing that you went through, right? Which seems like super beneficial to pinpoint exact data that we need. So I was wondering, like in our project, probably we should do this, but then also, do we really need it for our project? That's another part, right? Like, it's like, what is that? The fine line after which you have to go deep dive. Until that point, it's okay. ELK stack, the basic itself will take care.
Yeah. So if you just ask me, like, to some extent, like it is fine. So basically, the default mapping which ELK creates, so that should be fine. So another example. So let's say like I have like body, right? Stack Overflow body. Okay. So just trying to give you an example. So I wanted to have. So usually like we have all the HTML characters that are present in Stack Overflow body text, right? So I wanted to skim all this HTML tags and wanted to create index without HTML tags. So in that case, like it is mandatory for me to create these mappings. I need to go into that level of detailing.
Yeah.
Okay. Yeah. So if it is like so, you see this example. So this particular example. So usually like body, I don't want to create. So I will show you. So whenever you search for like Stack Overflow, so if you go to Stack Overflow, okay, and they have like search feature available here, right? So do you ever try to search with the entire body? So something like this?
No.
We'll never do that, right? So even it is not able to. So in this case, like if we do like default mapping, so I'll just show you my Stack Overflow mapping for the body. So this is Stack Overflow top, and this is my actual index Stack Overflow. So if you see the body part, so it has like a text and also it has like keyword. Okay. So there is one small thing which we need to observe. So there is a property, something called as like ignore underscore above. So if the data, if its size is just above like 256 characters, so even it will not get indexed as a keyword. Okay. So this is the default indexing. Like so, the default index will have this property like ignore above. So, but if it is 256 characters, so I'll have actual text which is analyzed, so which will be split into terms, and again like I'll have same exact 256 character string present. So if let's say like I have 1 million documents and I have both of these present, like text as well as like keyword present. But I know like I will never use this keyword, so I'll never query on this particular exact same sentence. Okay, so then it is waste of time to waste of resources like storage space also and also like other resources, right, for storing the data and retrieval. So then it is simply waste to have this keyword at all, because I know that I'll never issue this particular command on a keyword. So exactly index data. So I can simply remove this. But if I go with the default mapping, so it will try to index both text as well as keyword. But one advantage with the default mapping is it will ignore if the character length is above 256. So now you can just let me know your scenario. Like so, if you have like text indexing, and if you expect like more than 256 characters, so you'll not need not worry, because like it will be ignored. So it will not index as a keyword. And do you query with exact sentences?
No, we do not, right? Actually, what happens is, as I said, our use case is request and responses. So So the entire request body and the response body is queried. So
Okay.
not what is there inside the request body, right?
Yeah, got it.
So yeah, and then we do Kibana, and then we expand the entire payloads, and then figure out which one has our content. But the more
Yeah.
I think through, probably we can do deep dive, so that
Yeah.
we can avoid searching through the payloads.
Payloads, yeah, and storing unnecessary payloads. So another simple use
Correct.
case I use is like, so we store like all this data, like error data. So let's say like there is an exception and we log it to Elasticsearch. Okay. So in that case, so we'll have the complete stack trace, right? So when we have the complete stack trace, so it is obviously not possible to search with the exact keyword. So exact data that got indexed, right? Exact stack trace. So then we'll make use of like text only, because let's say like I wanted to query based on some method, like, so okay, how many errors are present in this particular method. So I'll just simply use the method name. So if that is the case, so it is waste of resources to query the entire object and store it as a keyword, right? So then I'll go with my default mapping and I'll just remove this field keyword mapping. So I'll just have only text mapping.
Yeah.
Seems like did I make sense? Well?
Yeah. And I get the picture. Yeah.
Yeah.
Yeah, maybe I can just add a couple of one use case that when we had to look at this mapping is so in our use case it's particularly for the e-commerce domain where the product inventory is what we index. Each product is indexed in it. So each product has at least 150 to 200 attributes that you indexing into the Elasticsearch, and obviously it's a huge index size. So, and when you onboard, let's say 4 million, 5 million SKUs or products, it's going to be huge gigs of data. So, one, looking into this mapping and trimming down what is necessary, what is not necessary, helps you trimming down index size. Two, when you're batch indexing these 4 million, 5 million SKUs or products, it's going to reduce the time, because otherwise each time if you're trying to have, because each time Elasticsearch is going to have build index for text and keyword, it's going to take time. So if you know exactly which fields you know exact use case, whether I'm using it as a text or I use it as a keyword, then you can those creating with the mappings, you know exactly okay what is useful pieces. So that gives much less time for index. Say for index, if your index time takes 4 hours, by fine tuning your mappings, you can reduce this to 2 hours or something. So that's one other use case where you have to work through your mappings. Just my 2 cents, but anyway.
Yeah. Thanks, Suresh. Yeah, Pavan, I think we pretty good, and also in interest of time. Thinking of wrapping. Seems like you got that. Hello, Pavan.
Yeah, I got disconnected, I think. Okay.
Oh yeah, he's right. Yeah. Yeah, Pavan.
So you're able to hear me now? So
Yeah. Now. Okay. Yeah. Sure. I think we can wrap. I believe, right, Pavan? Yeah.
Yes, sir. Yeah, so I think like we covered like a pretty good amount of topics. How do we actually index the data? And this is one of the major things, like indexing and then the mapping specification, as we discussed in the last session.
Yep.
Okay. Okay, so maybe in next sessions we'll see like how to actually query this data and other important things.
Yeah, sure.
Thank you guys. Like any other questions, so you can just ping me or on my email, or you can